Today we are going to discuss about the right-angled triangle and its unique characteristics. You may call it a unique triangle because it has a unique or a special characteristic that the other types of triangles do not have. Look at this triangle here. It is a right-angled triangle having this angle here 90 degrees, and these two sides are the adjacent sides because they make this 90-degree angle here, and this is the hypotenuse side. The hypotenuse side is actually the side which is opposite the 90 degrees angle. The length of this side here is 3 units, and here it is 4 units, and this is 5 units. Now, if you construct squares on both sides of this triangle, you will have a figure like this. You have the first square here, the second square here, and the third square here. Remember, a square is a quadrilateral with length of both sides equal. And in this case, this length here will determine the length of other sides. So if this is 4 units, here will be 4 units, 4 units, 4 units. If here is 3 units, here will be 3 units, 3 units, 3 units. The same applies to here. The length of here is 5 units, and here will be 5 units, 5 units, 5 units. So you have 3 squares there. Now, suppose you construct a series of horizontal and vertical lines for this square. And suppose the distance between the lines are 1 unit apart. In this case, in this square here, you will have a distance of you'll have a total of 16 unity squares, because the lines here are at a distance of 1 unit each for both the vertical columns and the horizontal rows. So here, if you count here, you'll have a total of 16 unity squares. So the area of this square here is 16 unity squares. And here, in this square here, if you count these unit squares made by this series of horizontal and vertical lines, you will find a total of 9 squares. So the area of this square here is 9 unity squares. In this case, in this third square here, you will have a total of 25 unity squares if you count these squares, because you have 25 unity squares made by this series of horizontal and vertical lines at equal distance to each other. So, in order to find out the special property of this right-angled triangle here, you may take this area and add to this area and add to this area, and I mean, you take this area, you add to this area, and equate it to this area, and see that special relationship. If you take area A plus area B, and you put the equal sign, and then area C, you will see that area A is having 9 unity squares, area B 16 unity squares, and this is equal to 25 unity squares of area C. So the sum total of areas of the squares on the adjacent sides is equal to the area of the square in the hypotenuse side. Now, you could find the areas of these squares by mathematical calculations instead of counting the number of unity squares in each of these squares. You could do it this way. Look here. You will take area A by taking this length times this length, and you get 9 unity squares. Remember, if you want to find the area of any square, you take the units of length of the first side times the units of length of the second side, and then you get the squares of units, which signify the area of that square. So the area of this square here is 9 units square. The area of this square here, you take this length, 4 units times 4 units, you get 16 units square. Area C here, it is 5 times 5, you get 25 units squares. Now, if you want to investigate the relationship between the sum of area of these two squares and in relation to the third square, you will have to take area A plus area B. Area A plus area B is 9 unit squares plus area B, which is 16 unit squares, you get 25 units squared. And since we know that area C is 25 unit squares, so area A plus area B is equal to area C, and they are both 25 unit squares. So with these explanations here, you can see any right-angled triangle should have a special property that the sum of areas of squares constructed on the two adjacent sides is equal to the area of the squares constructed on the hypotenuse side. Thank you.